to Kojo's Pre-Algebra. You ready? You notice I waited till it was dark outside tonight to do the video. There's nobody home. It's completely quiet. No phones ringing, I hope. Today we're going to talk about square roots. Now we've talked about those already a little bit. You know that perfect squares are numbers that when you take the square root, they give you the exact, comes out even, like the square root of 25 is 5. What you're going to learn today is you're going to learn how to show your work. I know, you got to learn how to show it, to manipulate the equation when there's a perfect square in it and you have to find the answer. There's a couple things you need to know. I'm going to get my tea here tonight. You know, I have a raspy voice. You guys all know that. So, I don't know, all this teaching and coaching all these years. So I have my cinnamon tea with a little honey, a little lemon. It really helps me. I have it from my favorite restaurant in Nashville. See that? It's got an L. It's Loveless's. Loveless's. Love. It's great. It was originally started by these two elderly women, and it used to be in their house, in their parlor, which was where they served people fried chicken and homemade biscuits every Sunday for brunch. It was incredible. And now they've branched out, they sold it, it became a restaurant right on the property, and they built it up, and it's so cool. I love it. I always go to there when I go to Nashville. Loveless's. Yeah, it's my favorite mug. All right, so square roots. One of the things you're going to learn in this lesson is how to use square roots in word problems. And you got to be very careful when you look at word problems. I've started teaching you to be very aware of the hints that they give you in the problem itself. So here's one. I give you a square here, and I say x and x are the side lengths. That right there tells you that it's going to be a perfect square because x, you can't use the same variable. You can't use the same variable to represent two different lengths. So you have to assume, since they're both x's, they have to be the same measurement. So therefore, this is a square. And then it's saying the area is 16 units squared. So they want you to find out what's the length of the sides. So how do you do it? Well, if we know that how do we find the area? Base times height. So if we're doing a square, the side square, s times s, or in this case, x times x, will give you 16. So x squared equals 16. Now there's two possible answers when you take the square root of a number. And you always assume that a is a positive number. Then x squared equals a has two solutions. X squared equals a has two solutions. We'll talk about why you assume that a is a positive number, or it can be 0. Here, x is equal, if we say x squared equals a, then x can either be equal to the negative value of the square root of a, because, very important, if we take the negative value of the square root of a and square it, that's the work that you have to show, and that's what you have to remember, and that is what's going to be difficult. Right? Yes. This is a very important rule, these two steps right here. So if you take the square, what happens is, I'll show you up here, if we go negative the value of the square root of a times negative the square root of a, when we multiply those, we get a negative times a negative, which becomes a positive, and then the square root of a times the square root of a becomes the square root of a squared. And what is the square root of a squared? That's right, it's a, because we know with exponents, whenever we divide, we subtract. So this is kind of division when you take the square root. So we just chop the exponent in half, and we get a. So that's where it is. If we take the opposite of the value of the square root of a, and we square it, we'll get a. The same thing is when we take if x equals the positive square root of a, because there's two roots that will give you. You can say a negative, if we had 25, you can say negative 5 times negative 5, or you can say 5 times 5. And because if we take the square of the square root of a and we square it, which means to multiply it by itself, so we have the square root of a times the square root of a times a is a squared, because we add exponents, right, when we multiply numbers with the same base. And then what is the square root of a squared? A. All right, that's very important. Now, you have to be careful here, because if we do this, you have to show your work. Oh, yes. You can't show it mentally. So you have to say, what are we doing? If I have x squared equals 16, then I have to show my work. How am I undoing it? I take the square root. But I don't just take the square root of 16. I have to take it of both sides, because this is an equation, because there's an equal sign and a variable. So we're going to say the square root of x squared and the square root of 16. Here's the tricky part. Normally, the square root of x squared is x. That doesn't change. But normally, when we take the square root of 16, it can be two different values. I had to be careful there. Don't want to. I was holding a pen cap. I wasn't shooting anybody to burn. Okay, be careful with that. All right, so square root of 16. You could have 4 times 4 or negative 4 times negative 4. Well, in this case, you should know the answer is 4 units. It's not negative 4 because we're talking about a distance on a square. Yeah, so there we go. So you have to be smart and you have to use some common sense to say, okay, I know that I'm talking about a figure, so the negative value is out of it. Well, let's see how we're going to use this in problem solving. Now, that's a word problem, and these are very important to show your work. So here we go. So here's an equation, and what we're going to do is, there's no distance involved here. No distance, no figure, or anything like that. It's just an equation. So we have to operate with it that way. So we start off by dividing by 8, because we want our variable to have a coefficient of, not just 1, positive 1. So we're going to divide both sides by 8, and we get n squared equals 16. Now, you can't just say n equals 4 or negative 4. You have to show me how you're going to manipulate the equation by taking the square root of both sides. You can do it right there on that step. The square root of n squared is n, because we have to assume that it's a positive value here. And then, well, it could be, it might not be, right? We're taking the square root of n. Over here is we transfer the negative. The square root of 16 can be one of two things. It can be positive 4 or negative 4. I told you this, I think, a while back. To write the answer is plus or minus 4. It's a positive 4 or a negative 4. Or you can write negative 4, 4. Okay, here, this is an equation. What are we going to do? We're going to add 25 to both sides. We're going to bring down our 11y squared, cancel that out. Oh, 11, 121. Oh, we're going to divide both sides by 11. We do not take the square root until we have a coefficient of 1 with the y squared. So we get y squared equals 121. Oh, no. Y squared equals what? 11. We take the square root of both sides. You can use a calculator. Square root of 11 is about plus or minus 3.32. That's all we do. Now here, you should say, oh, it's plus or minus 9. That's what we get. But you have to show me. You have to show me. So how do you undo that? You take the square root of both sides. Triangle equals plus or minus 9. Here's a tricky one. What do we take the square root of to get 6? 36, right? Well, how do you show it? You got to show me mathematically. You can do it in your head all day, but you got to show me mathematically. So if we take the square root here, how do we go backwards? We square both sides. Remember, that's this one. Let's see if I can show you. That's this little deal right here. Remember this rule? Right here. That's what we're doing. We're taking the square root of both sides. That's why that rule is so important. I don't want my L's to fall. So we're going to go square both sides. When we do this, it's enough to understand. We don't have to show that step up here when I said, you know, square root of triangle times square root of triangle is triangle square, and that's that. You can just simply go, well, I know that they cancel each other out, and it becomes that the triangle is 36. Okay? All right. So I want you to pause the video and do these two problems. One is a word problem, and one is just explaining. To the nearest tenth of a foot, what are the dimensions of a square room with an area of 450 feet squared? then the equation x squared equals -9 does not have any real number solutions. Why not? Pause the video, and when you're ready, turn it back on and check your work. All right, welcome back. Let's see how you did. Well, hopefully you saw that you had to round to 1/10 of a foot. And then right here, you had to say, oh, I need the dimensions. In the with a square room, so you know you're talking about side squared. In the future on a test, a great test question is to have this and then at the end say what's the perimeter. Because you have to find the side length to find the perimeter. Well, let's see what you did. While you're checking, I'm going to get my tea at my Lovelace's cup. Okay, so we set it up as x squared equals 450. We don't have to put feet squared. We're going to take the square root of both sides, and we get 21.213203. It's said to round it to tenths. So here's where I put the feet. I do not need to put about because it told me to round it, so x equals 21.2 feet. But it asks for the dimensions. So if you stop there, you're going to lose points because the dimensions are 21.2 feet by 21.2 feet. If I ask for the perimeter, you would then multiply that number right there by 4. The square of any real number is always positive. There is no real number that, when squared, will give you -9. And we've talked about that being the dealing with the imaginary number system, which you won't get into until Algebra 2. So I want you to write down 2 things you've learned and 1 question you still have. And I'll see you in class. Bye-bye.